Denise, are you with us?
Joanna, you see your answer in the chat box?
Yeah, I know. Thank you, Rick.
Making sure.
Appreciate that.
On our teams, whenever I run presentations, you can't see anything else, so I don't know who sees what.
Yeah, fortunately, the host and presenters can see the presenter chat, which is nice.
Hey, Rick, you make does your staff, are they required to do video when you do the teams?
I hope not, because we vary.
That's a lot. Yeah, because I was going to say, because New Jersey DOT requires video when you do teams. I'm like, ooh. I finally got my hair cut yesterday. Oof. I got a cut for the presentation.
Nice.
The only ones who have haircuts on my street are the dogs.
Or if you own a Flowbee. For those of us who remember Flobies.
I don't.
You attach it to the end of a shop vac. It would pull your hair up and the scissors would cut it off.
Hey guys, sounds like a bad idea all around.
Look it up. It was real. I think they still sell them too.
Guys, can you hear me? It's Denise.
Yes.
Hey, Denise. Yes, we can hear you.
All righty. Okay, I'm good.
All right, Denise, it is 9:30. Do you want to get started?
Yep, I do.
Well, thank you to everyone who is joining us today for the Coalition's TIS Web Summit. We'd like to welcome you. My name is Joanna Riegel from KMJ Consulting, and on behalf of the I-95 Corridor Coalition, soon to be the Eastern Transportation Coalition, we welcome you. This is a web summit. It was originally scheduled as an in-person and web meeting in March, and we're just happy to all be together, at least virtually. Just some information for you. All the participants are in listen-only mode. This meeting is being recorded. If you have any questions, if you have any issues with the audio, you can press *0. If you have any web, audio, any types of questions, you want to talk to Google, reach out to Justin Ferry, 484-557-7009. He pretty much knows anything. Presentations will be posted to the Coalition website following the event, as well as a Q&A summary, and you will receive, all participants will receive a link to that information in an email. To ask questions, we're going to ask you to use the chat box. So you simply type into the chat box, and at the appropriate times in between presentations or at the end of the event, we will be, Denise and the co-chairs will be monitoring the chat box, and they will direct the presenter to your question. At this point, I'd like to introduce Denise Marco, who is the TSMO director with the Coalition. Denise?
Thanks, Joanna, and thanks for everyone for being on the call today. I think it's a pretty exciting group of speakers that we have. I'm excited to hear what they have to say about emerging technologies that we're seeing in transportation. I think one of the pieces of the puzzle here on the screen is that, as you know, we're soon to be the Eastern Transportation Coalition. We are effectively going to flip that switch. Some of you have seen this slide several times, but July 1, we will be official. Website, emails, everything will be Eastern Transportation. It's welcoming, in a way, our new members of Tennessee and Alabama, and to really kind of promote the idea that we are beyond just the I-95 corridor. So that's official July 1. Another piece of information that we've just recently done, and it's in the pod for download. I noticed, I also referenced this yesterday on a large planning call we had, is we've completed a year in review for you for your executives to really talk about some of the work that we've done over the course of the year, whether it's in our program tracks of TSMO, freight, or innovations. It talks about our peer exchanges, our webinars, our RITIS group meetings, and some of our projects. So if you have a chance, if you haven't downloaded it or if you haven't gotten it via email, take a look at it. It is being presented to our executive board meeting, which is next Wednesday as well, to kind of show the value of what we're doing and how we're using our member dues. So it's in the box for download, the file box, if you haven't seen it yet. Joanna, I believe, too, that may go out as well as a follow-up with the link with the presentations at the end. Before we get started, too, I'd like to thank Mark Kopko. He used to be our travel information co-chair. He has moved on into becoming the key member for PennDOT as managing their connected vehicle program. So we wanted to thank Mark. We haven't really met since it's been about a year formally with a TIS meeting. So we wanted to thank him for all of the work that he did. But we also want to welcome back Kelly Wells. Kelly is from North Carolina DOT. She is their 511 Travel Information Services Manager. She has been very active in the RITIS user group forum for the past several years and has, I think Kelly's missed 511, so she's back as one of our chairs along with Mary Amin. So welcome back, Kelly. We're glad to have you. You're a great addition to the team. So, and the last thing, welcoming from our TIS co-chairs, Mary Amin, the Executive Director of NJTPA. Mary has been one of our longtime co-chairs. We love having her involved. She's got a great wealth of knowledge. And Kelly Wells, our State Trav Info Engineer. She is, again, one of our new co-chairs. So welcome to both of you. I think at this point in time, I am going to turn it over to Kelly. Kelly, who's going to review our agenda and take it from there. Go ahead, Kelly.
Very good. Thank you, Denise, and welcome everyone to our Traveler Information Summit. It is wonderful to be together. Like Joanna said, we can't be together in person, but I'm so thankful that we're able to be together on the phone and on the web. So it's just wonderful that we have this opportunity today. And if you're like me, I've really noticed that I appreciate these technical presentations from other states because I think we're so I think our worlds have gotten smaller. Most of us have felt like the world's a little bit smaller lately. So I have really enjoyed hearing from other states and just talking technical. And it's just sort of, for me, been like old times. So I hope you have that same feeling today. I hope you enjoy being together virtually. And I think you'll really enjoy the presentations that we have for you today. So let me just quickly run through the agenda. We'll first start off with New Jersey, a presentation on the use of voice assistance in the New Jersey DOT 511 system by Jim Hadden. And then we'll hear about the help system from Mary Farrell and John Farrell. Then we'll hear about commercial vehicle safety alerts from Rick Schuman and Gene Conti. Then we'll take a short break, and when we come back, we'll hear about PennDOT's TSMO performance program from Ryan McNary. And then lastly, Kevin Loftus will share some new and traditional media and traveler information. So with that, we will go ahead and just jump right into our first presentation. So I'd like to introduce to you Jim Hadden. Jim, I know we all know his name when he was formerly with the New Jersey Department of Transportation. He spent 30 years there, so congratulations, Jim, on 30 years at New Jersey DOT. Now he is president of his own independent consulting firm, Jim Hadden Consulting. When he was at New Jersey DOT, he managed the development and deployment of New Jersey's 511 Traveler Information Program, and he also managed the validation and integration of travel times on dynamic message signs across New Jersey. His bio says he was an active member, but I'd like to say he is an active member of the working group that we're on today, our Traveler Information Service Program, and he's also active on the VPP. And for those of you that don't know, we'll use the acronym VPP all day. It's the Vehicle Probe Project. So it's the program run through the coalition, run through the University of Maryland, where we're able to buy probe speed data from INRIX or TomTom or HERE, and we all use that data for various things. So if you're new to our group, you'll hear the term VPP all day, and that's what it represents. So he's active on the VPP initiative as well. And he had done a recent project for FHWA, which is the Federal Highway Administration, on their center-to-center reference implementation project. He's worked on Transcom's Battle suite of web-based analytical tools, and most recently on New Jersey DOT's 511-based voice assistant. So this is I think this is one of the kind of newest and coolest things I've heard about lately. So with that, I welcome Jim Hadden.
Thanks, Kelly. You know, it's
Jim?
funny. I'm here.
Okay, gotcha.
Okay, there we go. So no, thank you. I appreciate that. You know, I always found a great value in the coalition and the travel information group, and it's nice to be back here with the group. And you know, I've been out for almost 5 years now. So it's good to be back, and it's good to see some of the familiar names still involved in the group. So with that, if we could start the slides, please. All right. How do we, I need to move to the next slide. Oh, never mind, I got it. So, history of 511. So I want to talk just briefly on the history of 511. As 511 initially was designated by the FCC back in 2000 as the single travel information telephone number. It was initially 511 was a phone call that travelers made. At the time, there were over 300 different traffic travel information phone numbers that existed across the country. And the FCC allotted 511, which was a big deal at the time because the N11 numbers were of value. AASHTO, APTA, and ITS America established the 511 Coalition to support states in their efforts to deploy. And the goal was to help travelers, commuters make informed travel decisions. And the information was updated every few minutes. From a technology perspective at the time, we had cell phones, but camera phones came out. YouTube came out in 2000 and 2005, Twitter 2006, and the first iPhone was released in 2007. From New Jersey's perspective, they launched their first 511 website in 2006. It was a static website, and again, it was a phone system. This was the technology that was available at the time. In 2010, we developed the dynamic website that had real-time information, had personalized travel system, personalized travel profiles. Popular travel routes were there. We had Twitter feeds that we developed, XML feeds that today we have over 400 subscribers to those XML feeds. And in 2013, we started to share information on a regional basis with New York, Connecticut, and the Philadelphia region. And most recently, in 2019, we transitioned from that website off of Adobe Flash. As you know, Adobe Flash is end of life at the end of 2020, and we transitioned to an HTML-based website. The department has always seen, the New Jersey Department of Transportation has always seen the value of 511 in supporting state and regional transportation initiatives. Whether it was a Pulaski Skyway, the Helix Fix, highway traffic safety, drive sober or get pulled over, they've always seen the value to 511 in supporting those other transportation or multimodal initiatives. Phone use obviously has dropped off as technology has changed, but the website really remains strong. From January 19 through February 2020, we had over 4.5 million visitors to the website. And now with the refreshed website that was just recently done, it's mobile friendly. So if you open your mobile browser, do 511nj.org, you get to the website and you get everything there, including cameras and everything else. There's no official 511NJ app just yet, and I'm going to preface that as yet because when I talk about Siri, you'll find out about that. Again, the department really sees the value to this because there's the Googles and the Waze of the world just are not going to customize data or tailor it to the department initiatives. And probably most importantly, as we talk about the voice assistants, the department has always been concerned with distracted driving, the cell phone or smartphone use while driving. It's an offense to drive with your phone. So how do we promote, how do we do this and move forward? Even if you look at Waze or some of the other applications out there, they require some type of interaction with a smartphone to get information. Voice assistants, however, are just a little bit different. Some interesting facts about voice assistants. they actually go back to the early 60s when IBM developed Shoebox, which recognized about 16 digits. And you can see through this list that over time, voice assistants are nothing new. 2011, Apple launched Siri. 14, Amazon launched Alexa. 2016, Google Assist. 2017, Alexa, Echo Dot, Google Home, et cetera, launched worldwide. Some statistics about the voice assistants. Google Home, there are 52 million devices worldwide, 43 million in the U.S., but only about 5,000 skills. Alexa devices, there are about 100 million devices worldwide and over 100,000 skills. Cortana, which is really computer-based, there's about 141 monthly users, but when we finished the development of Cortana, they just announced that they're phasing out the voice assistant skills, but there are only about 230 skills and they're stored anyway. Apple Siri is a really a completely different animal because they have about 500 million devices or customers out worldwide, but 1.85 million of those have Siri. And the way Siri works with an app. There's no voice assistant dedicated for traffic information. It feeds off of an app. So if you have Starbucks, Siri will feed off of the Starbucks app. If you have Dunkin' Donuts, it'll feed off the Dunkin' Donuts app. And most recently, there was an Associated Press article that said about 20 million vehicles are going to be shipped in the U.S. in 2023 that are going to come equipped with Amazon Alexa, Google Assist, or Android Auto, or both. Okay. From Alexa's perspective, these are just a few of the vehicles that are going to be coming with Alexa built in, and there's more coming. I was out the Consumer Electronics Expo in Las Vegas this past January, and they actually had a Lamborghini that was out there that was completely outfitted with Amazon Alexa. And if you can't afford one of those, Amazon does list vehicles that have it, that have Alexa built in. And if they don't have it, what Amazon has done is they've had the Echo Auto that can be plugged into your cigarette lighter. There's a whole integration page they provide. You need a Wi-Fi hotspot, so if your vehicle has Wi-Fi, you can plug this in, and it truly allows you to be hands-free. The voice assistants from the Google side, or the Android Auto, these are some of the vehicles that are out there as well. If you can't afford an Aston Martin or a Ferrari, they also have a list of vehicles that have it as well. The subtle difference here is that Android does not have a device that can be placed in the car like the Echo Auto. So you have a skill that you really want to do. Once you enable it, well, the interesting part about this is it's available across all the devices with that brand. So if you have a skill that you enable on Alexa, it's going to be on your Echo Dot. It's going to be on your Echo Show, your Auto, etc. And if you have the app on your phone, it's going to be available on your phone as well. Same thing for Google, the Nest Mini, the Home Hub, the Nest Max Hub, and also the smartphone. And again, we're looking at for the New Jersey traffic application, we're looking at having this available on multiple platforms because we don't know how people are going to use it. We just know they want the information. So when developing the New Jersey traffic app for 511, what was interesting is Google will not allow a number in the development of a skill. So Google is a skill. Oh, I'm sorry. Amazon is a skill. Google is an action. The Google actions do not allow you to use numbers in the development. So what we did is we branded it as New Jersey Traffic, and then when you go whatever brand you have, we have the logo to reinforce that it is coming from 511. So the upper left-hand side would be what you would see for Google. The upper right would be for New Jersey Traffic. There is an app for 511 that we're going to be using for Siri, which has not been deployed yet, and also for Cortana, which has not been deployed yet either. Each one of them has we talk about differences. There are not really differences, they're nuances, because we tried to standardize everything as much as possible. However, when you use Alexa, it's Alexa open New Jersey Traffic. When it's Google, it's Hey Google, talk to New Jersey Traffic. Siri, it's Hey Siri, New Jersey traffic. In Cortana, you can use anything. You can say launch, ask, open, New Jersey traffic, and it works for you. From the 511 New Jersey traffic perspective, New Jersey traffic app, skill, action. We base it off the real-time information that's available on 511. We based the travel times back when the website was deployed. We did a travel time link base. It's called popular travel routes that sits in the top center of the page. So we based those travel times off of that as well. And really, we wanted to make the interaction with the voice assistants as similar to the phone system or the IVR as possible. One of the other requests that the department had for us was for the ability to put a floodgate into the app. So let's say you have an Amber Alert. The Operations Center has the ability to push an Amber Alert out through a floodgate. So when you activate a skill or an action, the floodgate will play at the very top before it does anything else. Very similar to the IVR. And again, everything's based off the current incidents on 511, the popular travel routes. The difference here with the popular travel routes, instead of giving travel times for everything, because they're broken down into segments, what we did is we only play a travel time for information when a segment of the trip is 50% above the historical travel time for the time that the request is made to the system. Otherwise, the system is going to play trips along the roadway are normal for this time of the day. Again, floodgates, we go through, and if there's a floodgate that sits along the top of the page, we can take those and add those. We talked about whether a snowstorm, an Amber, or whatever they want to do, they can post it there as well. With that, I'm going to ask Justin to give me control for my screen. I'm going to share my screen. So what we did was the department asked us to do two videos to show people how to enable the skills on Google and on Alexa. So what I'm going to do is I'm going to play those for you, and then I'm going to go through and do a demonstration of the skills. Hang on one second. 511 New Jersey, traffic and travel information is now available on Google Assistant. To enable the New Jersey traffic skill on your device, visit www.511nj.org. In the right-hand column, click on the Works with the Google Assistant image. The New Jersey Traffic Google Action page will appear. Mouse over to Send to Device and select your device. Once the Google Action is sent to your device, Google will ask you if you want to provide your name and address associated with your Google account. Say yes, and Google will confirm your request. This will only happen once during the initial setup. The New Jersey Traffic Google Action is now available on all your Google devices. To use it, just say, "Hey Google, talk to New Jersey Traffic." Still have questions? Visit the Frequently Asked Questions page on the 501nj.org website for more information. So that's Google Assistant. You'll see, I'm going to play the Alexa enabled video next. That's about 40 seconds. Just we talk about nuances. The nuances are in the development and the enabling of the skills of the action. So here's the Alexa. 511 New Jersey, traffic and travel information is now available on Alexa. To enable the New Jersey traffic skill on your device, visit www.511nj.org. In the right-hand column, click on the Just Ask Alexa image. The Alexa New Jersey traffic skill page will appear. Mouse over to Get This Skill and click Enable. The New Jersey traffic skill is now available on all your devices. To use it, just say, "Alexa, open New Jersey traffic." Still have questions? Visit the Frequently Asked Questions page on the 511nj.org website for more information. Okay, so we did those for the department. When we launched these, it was right at the beginning of the coronavirus pandemic, and so we've kind of fallen off the table a little bit because of there's really hasn't been much traffic going on right now. So having said that, let me go through, and I want to demonstrate. I'll do a brief demonstration of, first I'll do Alexa, and then I'm going to do, I'll do the Google Assist. So here's Alexa. Hang on one second. Alexa, open New Jersey traffic.
Welcome to the New Jersey Traffic Alexa skill. Here you can find out information for 2 services. Select 1 for events and 2 for travel times.
2.
Please, provide roadway name.
George Washington Bridge, westbound.
Route 46 from Fort Lee to the Alexander Hamilton Bridge via the lower level. Distance is 4 miles. Travel time is 13 minutes. Route 4 from Fort Lee to the Alexander Hamilton Bridge via the lower level. Distance is 4 miles. Travel time is 12 minutes. Say next for next trip, or say main menu.
Next.
Interstate 95 from Interstate 80 to the Alexander Hamilton Bridge via lower level. Distance is 6 miles. Travel time is 15 minutes. Say next for next trip, or say main menu.
Main menu.
Here you can find out information for 2 services. Select 1 for events and 2 for travel times.
Events.
Do you want to know events by city name, or by roadway name?
Roadway name.
Please, provide roadway name.
Route 17.
There are 5 events available. Event 1 as of 9:30 a.m. There's construction on Route 17 southbound between Moonachie Avenue in Woodridge and East Union Avenue in East Rutherford. Right lane closed until 2:30 p.m. Say next for next event, or say main menu.
Next.
Event 2 as of 9:01 a.m. There's construction on Route 17 northbound at Garden State Parkway in Paramus. Left lane closed for repairs until 3:30 p.m. Say next for next event, or say main menu.
Main menu.
Here you can find out information for 2 services. Select 1 for events and 2 for travel times.
Goodbye.
Goodbye. Thanks for using New Jersey Traffic.
So that gives you a sample of what Alexa sounds like. Let me go through, and I'm going to do Google. I'm going to do Google Assist. 1 second. Hey Google, talk to New Jersey Traffic.
Welcome to the New Jersey Traffic Google Actions. Here you can find out information.
2. 2.
Please provide roadway name.
George Washington Bridge, westbound.
Cross Bronx Expressway from Jerome Avenue to Interstate 80 via the lower level. Distance is 6 miles. Travel time is 16 minutes. Cross Bronx Expressway from Jerome Avenue to Interstate 80 via the upper level. Distance is 6 miles. Travel time is 15 minutes. Say next for next trip, or say main menu.
Main menu.
Here you can find out information for 2 services. Select 1 for events and 2 for travel times.
1.
Do you want to know events by city name or by roadway name?
City name.
Please provide city name.
Mansfield Township.
There is no event available. Say yes to know about another city, or say main menu, or say goodbye.
Yes.
Please provide city name.
Marlborough Township.
There are 3 events available.
Event 1 as of 9:01 a.m. There's construction on Route 18 southbound north of exit 29 Tennant Road, County Road 3, County Road 520 in Marlborough Township. Ramp closed until 2:30 p.m. Say next for next event, or say main menu.
Main menu.
Here you can find out information for 2 services. Select 1 for events and 2 for travel times.
Goodbye.
Goodbye. Thanks for using New Jersey traffic.
So that gives you a flavor of both of the skills. So with that, let me come back to the presentation. So some of the lessons learned we had this is develop something that's user-friendly. Don't try and recreate the wheel. People are used to IVRs and the interaction with an IVR. So we chose the IVR interaction to start, and we also wanted to have something deliverable, so incidence travel times are where we started. Standardize your data structure as much as possible. In the development of Siri and the Siri app that talks to the New Jersey traffic app, when we said the word city, Apple would say Siri, and it wouldn't understand us. What we actually did, we actually had the city, we made it city name in all the platforms, so it would be, again, so we have everything as similar as possible across the platforms. Again, branding across platforms, numbers are not allowed with Google, so we chose New Jersey traffic. In terms of development, Alexa and Google Assist allow for development sites before pushing to production. Siri and Cortana do not. Allow plenty of lead time for code review. All platforms, regardless of the type, will review your code line by line. They will either accept, reject, or ask for clarification. I cannot stress testing. Call flow testing plan, follow it, and you can never test enough. Marketing. All platforms have guidelines for marketing products, including images. Each one is different. However, they are all the same in stating that they are not virtual assistants, they are voice assistants. And then once accepted, what we did with the department was we did a soft launch. It takes when you deal with the different platforms, they have a different time frame for pushing to production. And so what we did is we launched it a couple days before the department did the official press release and push on social media. And so the soft launch was pushed it out a couple days beforehand. 1 or 2 people may have found it beforehand, but that's okay. But then the official department, and what that does, if we have a bug or we found something in the production environment that we needed to fix, it gave us the flexibility to go back and do it. Lastly, Siri Cortana, we're waiting for some direction from the department because of the whole coronavirus pandemic. These 2 applications got pushed to the back burner for now. We're hoping in the next month or so to have that discussion with them. And then last thing, as part of the original deployment, we wanted to have location-based information, but each platform worked just a little bit differently in terms of the information they provided. And so we decided we're not going to deploy that initially, and we're going to take a deeper dive discussion with the department to determine the best approach to provide the best information. For example, if you're driving up close to the Lincoln Tunnel or the George Washington Bridge and you ask for events near me, and your radius is even a mile, you could get 20 to 30 events to play during the request, and that's not a value to the end user. So we're looking at finding some, whether we do it by direction or some other way to get the targeted information to the user as quickly as possible, and the information that they're looking for. With that, that's what I have. Does anyone have any questions?
Thank you, Jim. That was wonderful. There is one question so far in the chat box, so while other people are typing theirs, I'll go ahead and read that one for you. Ray Hallavant asked if this was developed in-house or through a vendor.
This was done through a vendor.
Okay, very good. And while Crystal's typing, I'll ask you, what gave you the idea to do this, or New Jersey DOT the idea to do this?
Well, as I mentioned earlier, the department's always, particularly with this most recent commissioner, because I've been around for a long time, and some commissioners have liked 501 more than others, and this commissioner is really about providing information out to the public as best we can. And we all know from people that have done 501 systems, the usage models and numbers are changing. And so we know the phone is dropping, but people are accessing our information right now through Waze and through other platforms. And this is sort of the new technology that's out there. You saw that from the Alexa perspective. If you were to ask me which I thought was the easiest to work with, I would say it's Alexa, because they make it so easy to enable. Once the skill's enabled, it's everywhere, and they're in the cars, and you see the commercials saying, "Hey Alexa, open, set my heat to 55 degrees." Well, it answers a number of questions. It's technology that people are now getting in their vehicles every day, and if we can provide that information to them hands-free as quickly as possible, that's what we wanted to do. And so that's why we kind of made the shift. We still see the numbers drop from the phone perspective, but the web is still there. So there is truly a value to the information we provide, and this is just where technology is going right now.
Good. Okay, a couple others. Crystal Underwood asked, how long did it take from start to soft launch for this development?
Less than 6 months.
Oh wow.
Without doing the location based, it was a little less than 6 months.
Okay, good. And yep. There's a question, will you be customizing it to be tailored to origin destination of the user through Google Maps, for example?
There's been some initial discussion with the department about tying in there's personal profiles. We have 35 or 40,000 personal profiles that have trips from point A to point B that they can do, time of day, direction, and they can get incidents and that type of thing. It's a discussion we want to have, that the department wants to have. But again, it was something we talked about, but we wanted to get an initial deployment out. We wanted to do something that was deliverable. And we wanted to get it out quickly and get it out and get it in their hands and get them used to it. But doing something with tied to a personal profile is something that we are looking at doing. Yes.
Okay, good. And another question: can geofencing be used with the voice assistant?
It can be. That's where sort of the challenge came in, and that's what kind of gave us pause. So if you use, sadly I've had both of these devices in my cars for months trying to test them. If you use Google Assist and you use that in your vehicle, that will give you location. That will use the location. But when you register, everybody wants their devices registered. Alexa, when you register your device, you're registering, this is what we didn't know, you register at your home address. So I'm in Jersey City trying to test Alexa, and it's giving me events around Trenton, New Jersey. And we're like, why are they asking us, we asking for location? What it's doing is asking for the location that the device is registered. Now, Alexa does have code to allow you to request information by location of the device itself, but we're so far into the development, that gets back into the whole question about, do we do geofencing? It is, if we did a mile, that's something you could do, but if you get around Jersey City, you could get 30, 40, 50 incidents at a time during rush hour, and that's not a value to the user. So it has a deeper dive that we have to do with the department to kind of come up with the best approach for that.
Excellent. Very good. Well, we look forward to hearing, the next time we have one of these events, would love to hear what you've done in the coming months, because it sounds like there's going to be a lot of opportunities to do new and cool things, and the feedback you get from your users, and would love to hear more about this the next time we get together, okay?
Absolutely. Thank you so much for having me come in and talk this morning. If anybody has any questions, just feel free to let me know. I'll be on the chat all morning. So.
All right, very good. Well, thank you so much. We appreciate it, Jim. And now look at us right on time. We will move. Yes, great. We'll move right on to our next presentation. So our next presentation is updates on the HELP system for Pennsylvania, Georgia, New Jersey, and Maryland. And we are joined today by John and Mary Farrell. Mary is the president of Information Logistics, a technology company located in New Jersey. She has been involved in technology since her days as a math major. I love that, Mary, working in the college computer center. My husband is a math major, so I'm right there with you. From her first job doing research at Bell Labs to her current company, Mary has worked with system design and software development for the military and a variety of industries, including insurance, legal, and now transportation. She's specifically on addressing the technology needs of the transportation industry for the last 10 years. Her company's innovative ideas and the technologies that her team developed have won many local and international awards. And then also her co-presenter is John Farrell, who is the Vice President of Project Management. He oversees a number of technology projects to improve ITS and emergency operations. Before coming to Infologistics, he was a staff sergeant in the U.S. Marine Corps and spent 10 years working in local government. John brings a wealth of organizational government project management experience, as well as a passion to use technology to facilitate emergency preparedness and generally communicate with the local community. So I have to say I have heard the HELP presentation probably 6 or 7 times, and every time I hear it, I thoroughly enjoy it. So if you've heard this before, do not say, oh, I know about this HELP stuff, because every time I hear this presentation, I learn something, and I just really enjoy the way John and Mary bring the technology, and they just really seem to understand as state DOTs and as transportation professionals what's important to us. So I really enjoy their presentation. So please help me welcome John and Mary.
Well, thank you so much, Kelly. I appreciate it, and good morning to everybody from beautiful downtown Pennsauken, New Jersey. I know it's a famous place for everyone. John's going to be running the slides today, so John, if you click over to the next one, because he has most of the work to do. I just wanted to briefly run you down what we're going to just touch on today. So the very first thing is a very brief review of what the HELP system is, just to refresh anybody or to let anybody who hasn't heard it before see what it is, but very quick. The next one is we have a number of updates to give you regarding iPause and WIA. John's been in touch with them a lot. Some of the usage that's gone on over the past couple of years, lessons we've learned. Then I get to do the exciting part of what's next, some of the features that we've updated the system with, and we're also going to talk to you about the COVID-19 implications for this utility, and then take questions and answers. So with that, I'm going to have John start off. John, take it away.
Thank you. So I'll start by making sure everybody has at least a basic understanding of what the HELP system is. Basically what it is an emergency communication system, and it allows the DOTs to reach out and establish either one or two-way communications during major roadway closures that have traffic queues or during other emergencies. Part of why this is a really interesting, innovative system is that there's no app needed, there's no pre-registration needed. Users actually get the ability to opt in during an individual event for each event, and the message that they get is geo-targeted to a specific area so that you're not just blasting this out to everybody that has ever heard of your 501 or other emergency notification system. The way that is done is through the use of a federal emergency system called the Wireless Emergency Alerts, and I will be explaining more of that later in part of the updates here, as that system has been improved recently. So let's take a look at the use cases for where HELP alerts are typically used. The most common situation is a traffic queue on a roadway where you want to establish two-way communications with the people that are stuck. Let me start by saying this is not a tool for your typical downtown rush hour slow traffic. This is the kind of situation where you have a roadway, typically a limited access highway, and it's going to be closed for a long time, like several hours. and you can't get the traffic that's caught behind the accident off of the road quickly. So you need to get in touch with those folks to make sure that you're doing safety checks on them, to give them information about the closure, and if you like to collect information from those folks, be it their individual needs if you want to hear that kind of stuff, or they can actually provide intelligence backup if for some reason you don't have great eyes on the ground there. So what you're seeing on the image here on the right is an actual picture from a real activation of the system. And what you're looking at is all those dots are different individual vehicles and phones that have registered for the communications during that emergency. They're all plotted on a map, so you can see the layout of what your traffic queue looks like for everybody that registers. And then you can wind up dealing with your strategy for extrication of the crash folks or people that need to get out or turned around quickly as you go along. Now, this system was inspired by a winter storm in Pennsylvania, and that's, of course, a good use case because, the cars couldn't move for a long time and people were stuck on the road. However, it can be for any kind of thing that shuts down your roadway. That could be something like, as you see on the screen, an oil tanker fire that's made it so that, in that case, you might not just have the roadway shut down, but you might need to actually alert people along the sides of the road if it's a commercial corridor. Or when you unfortunately have fatal accidents, we know that those investigations can take a very long time, and if you can't turn the queue around in the back, you may need to communicate with the folks that they're going to be there a while. Somebody's obviously having a much worse day than they are. And then just basically any section of roadway that is blocked and you can't turn the traffic around, the system can be used to reach out, get in touch with folks, let them know what's going on, provide them safety tips, and get information back. Again, that is the most common use case by far. And to simulate this, we actually have a demonstration event going on right now for anybody that would like to try it and see what it looks like to be on the public side of this. You can actually go to the website that, let me see if I can get this arrow to work. There's the website that's going to be at the bottom of the screen here, i2helpdemo.com. It's also in the image here. If you go to that site, you're going to actually be able to see a pretend event that I've created actually around the Information Logistics Office, but you can still register and see what the public sees when they receive this emergency alert with that information on there when they get that. So moving on to the next use case that is common for the system is, I should say less common for the system, is when you want to send a one-way alert. So what this does is this allows you to create a geo-targeted area and send an emergency alert, but it does not give the user the ability to register to receive recurring updates from the DOT. This is simply a way of sending something out so that you're warning people that there is an issue somewhere and that they need to be aware of it. This was used on the Pennsylvania Turnpike in 2017. There was a bridge closure that was unexpected due to an inspection find, which is a good thing. But it can also be used for a lot of other issues, whether it's you're turning a roadway into for contraflow traffic. Flooding's a great one because we've seen that happen the last several years in a lot of places where major sections of big roadways are flooded. Good way to avoid the area. And the other one that we talk about, especially here at INRIX say a lot, is the dangerous slowdown conditions. And this is when you're looking at something, like let's imagine that you're rerouting traffic off of an exit that goes into a rural area from a limited access highway, but it's bypassing an area that, the area that's blocked usually has a lot more traffic. Well, if the local roads can't handle it and it backs up onto your interstate, you run the risk of having one of the situations where people are going 70 miles an hour and then they're going down to 10, 5, or even 0 as they're stopped with an unexpected queue forming on the highway for people trying to get off. This is a very efficient way of warning people about that. And it's also nice because in addition to the screeching sound that the emergency alert makes, that one that you hear for severe thunderstorms or amber alerts, it will also, in most cars and then on most individual phones, actually read that message to you so you won't have to actually look at your phone for that part. And speaking of the INRIX data, one of the benefits to the system is that this is a joint offering with INRIX. So all of the data that's in there on the map that the administrators get to see will actually show you queues forming, extending, and then shrinking again, so that as you look at this and you're trying to decide what area to alert, you actually have the INRIX XD very detailed data on there helping to inform that decision so that your operators can use the combination of what they know about the roadway and the roadway dynamics and what the INRIX data is telling them is happening on the roadway at that point. So that is my incredibly quick overview of how help works and the stuff that some of you have heard before. Now I'm going to switch into some stuff that I haven't been talking about as much because A, a lot of it's new, and B, it's just stuff we haven't explained as much in the past. The first part I want to hit that we always get a lot of questions about is the initial alert to the travelers to let them know that this system exists. And that's the one I keep referring to as the emergency alert that's sent out. So this is a system that's owned by FEMA, at the federal level, and their system is called IPAWS. And IPAWS is the Integrated Public Alert and Warning System, which is basically the same system that will do both emergency alerts on your cell phone, the wireless emergency alerts, as well as the traditional ones that you can hear beeping on the radio and TV for, this is a test, this is a test, those kinds of messages, all that. It's all through the same system. Well, what's basically happened is we have been authorized to go ahead and use that for these types of emergencies because they are considered public safety hazards. And so this has been thoroughly endorsed by both FEMA and the FCC that winds up regulating on the cell side of the house for how this has gone. Now, how they actually work is kind of neat, and I want to explain it because there's been some recent developments that have made the system even better. So why are we going to use the we in the first place? Well, first of all, it's got a unique way of getting folks' attention. That distinct alerting sound that kind of screeches on your phone starts vibrating, it gets your attention very quickly. The fact that it's geo-targeted is wonderful, and I'm going to explain how that's reduced with this graphic in a second. But the one that I think might be my favorite is actually the third one here, that there's no subscription needed, because 99-point-something% of phones that are done in the U.S. Wind up with this capability built into them innately, that nobody has to do anything, don't have to subscribe, it's just there ready. And it does it on a broadcast line that avoids cell congestion. These take precedence over voice and text messaging on cell towers, so that in an emergency, when a cell tower is nice and flooded, these messages will still get through, even if a voice call or a text message won't. So let's see how they work. On the image on the screen, what you're hopefully seeing right now is my section of roadway with 2 cell towers on. I got my 2 cell towers. And the way this typically works is we have a geofence that the operator at the DOT draws, and that gets sent, and it's going to cover that area of roadway, which is obviously served by these 2 cell towers. The way we originally worked was it would send the WIA message, the emergency alert, to those 2 cell towers, and they would distribute it to every phone that was connected to them, meaning within a broad radius of that area. The guidance was that the cell companies had to get the message to as many people as possible in the polygon, but there wasn't so much worry about bleed over. It was said to please minimize it, but that didn't always happen. Well, what's been happening now is it's getting tighter. And the reason it's getting tighter is because the FCC has now mandated that this should not spill out past the sides of the polygon more than 1/10 of a mile. And the way the cell companies are doing it is they're still sending the message to those cell towers, but then they're actually having the phones determine, based on the phone's latitude, longitude, whether it's inside the buffer zone of that shape or not. What this does functionally for the DOT is it allows them to create a tighter box around the roadway section that they want to alert, so that they are not having so much spillover and alerting people about a roadway issue that don't necessarily need to worry about it because they're a house that's close to the roadway. It won't completely eliminate that, but it reduces it substantially. So that has been a tremendous benefit that has come to this wireless emergency alerting system just in the past few months, and that our system is equipped to handle at this point. I also want to shift over to how the system has been used, particularly in Pennsylvania. And I know that we have several folks from Pennsylvania DOT and the Turnpike on the phone. So if you have anything you need to add to this, please put it in the comment box, and I'll try to make sure I get to it. But one of the questions we've gotten about Pennsylvania usage in particular, because they've been on the longest, is, hey, especially when I'm talking to other states, hey, what is the pattern to how it's used? So I tried looking at data, and I tried looking for patterns a few different ways. First, I looked over time, and I said, is this really something that's just used in the winter in Pennsylvania, because it's a state that gets a lot of snow, a lot of different geographies? And the answer was that, well, it's used more in the winter, but it's certainly not used exclusively in the winter. It's actually been used every month of the year except September. And I have a feeling that if Pennsylvania got hit harder by hurricanes on a regular basis, September would have more usage, but that's purely speculation on my point. So really, there wasn't much time pattern. I mean, some of these activations in the summer are in perfectly clear, beautiful days. It's just unfortunate accidents on sections of roadways that are hard to pull the trapped queues off of. I also tried looking at geographic patterning across the state, and as you can hopefully determine from this image, there's not much. We're hitting a lot of different geographies here. We're hitting some areas that have lake effect snow, a lot of areas that don't have lake effect snow. The only consistent pattern I can tell you on here is that from a geographic perspective, these activations are happening on limited access highways, and that's about it, and they tend to avoid urban areas. The limited access highways part, I can tell you, is by design. That is by policy that is set by PennDOT and the Turnpike, Pennsylvania Turnpike, and that makes perfect sense because that's also the areas where you're more likely to have distance between exits. And I think that's also probably why it's not in urban areas, because you tend to have more exits more frequently, and diverting traffic and rerouting, I think, tends to be a little easier in those areas. In looking at, we've got Pennsylvania. New Jersey is also on board with us, so we're excited that they have come on. Georgia and Maryland have as well in using the system. Neither one of them has officially launched yet, but we're very excited for those to happen very shortly. So we're seeing a lot of interest from different places who are seeing, hey, this is a good idea, and we want to be able to talk to people who are in these tough situations. In talking to these different states, one of the things that I wanted to share very quickly is just a few lessons that we've taken away during our setup process from the policy and procedure side of the house. Basically, the biggest thing that I want to point out to most folks is that when you're using this system, especially during setup, it is critical that your state emergency management agency is brought into the process as early as possible. The reason is because they are the ones that are the owners of the permission to use the emergency alerting system. And in most cases, they become the ones that do the actual approval of those alerts once they're requested by the DOT. And that's where you get into the second point I have on here about the COG ownership. The COG is really who's responsible for it, meaning who's allowed to actually approve the alerts. And typically that's done by the emergency managers, but the DOTs can actually apply to get one themselves. Again, you still have to work with the emergency management agency. The trick with that is, in, I believe, every state so far, the process of taking care of the emergency management coordination has taken a good deal longer than the technical setup of the system. So that is something that has been a consistent slowdown in the setup process. But that policy is incredibly important, so I also don't want to rush that, but it's just that coordination is really important. We've also seen that with the policy, flexibility is important. And activation sooner than later tends to help with a lot of the communications with the people that are stuck. People would like to know something sooner rather than waiting too long. Not to say that you should activate it really quickly when you're not going to necessarily know if you have a long queue, but when you see that it's going to be there a while, the sooner you activate it, the more people tend to appreciate it. As a final point on this, I'll also say that practice becomes important, and the system does get installed with both a practice demonstration version that you can use for testing that does not go to the public, as well as a live one that does wind up going out, but you can practice as much as you want on the demonstration version of the system. And with that, I will turn it over to Mary to take over the next couple of slides to get to some of the exciting stuff.
Well, thank you very much, John. And I just want to say that, that was, there's other lessons that we've learned in the course of doing this. So again, let us know if you have any questions on this, and we'll do it. For those of you who've registered with the event, we've been going back and forth a little bit with folks. So if anybody has any questions, you can enter them here on the chat. You can bring them up on the text, whatever you'd like. John, could you please switch these slides for me? And one more. So what's coming up on the horizon for this product? Well, let's look at a couple of things. Now, the first two bullets on this, the adaptive layout. So we have made the layout of both the end user part was always adaptive, but the operators who sit in the TMCs or in the EMAs, we have also made that entire interface adaptive so that they can use it from their iPads or cell phones or whatever they're working at that point. And it's much easier now on mobile devices. We've also added an ability to predefine alert areas and save them. So if you know that every winter you have an area that, boy, it gets this type of situation, sadly, every year or something, you can save it ahead of time. You don't have to join the geographic boundaries on it and put them up later. In talking with several of the EMAs around the country, many of them mentioned that it would be helpful for them to get more information about the interaction between the system and the iPause WIA message, you know, that that you get on your phone, the data that goes back and forth to facilitate that. So we've already put that into the systems as well. So the EMAs now can get all the information that they want, basically. So those three are in there. Now, the next one is really interesting. This is the stuff that John was talking about with the next version of WIA, where now you can do stuff like you can put your stuff in English or Spanish. You're also allowed 90 or was it 360, I think, characters in that initial alert, which gives you a lot more flexibility for phones and devices and all that are enabled that way. So the system has already been adjusted to handle all of that, and we will be giving a series of webinars over the course of the summer that can be refreshers for all of our customers, and we'll certainly be running ones for anybody who's interested in learning more as well. But we will be training in the use of these new features, how to access them, what to be looking at, et cetera. But the really exciting stuff is the stuff that's coming soon, because I like the stuff that, you know, is yet to be integrated in P2C. So the first one, we were thinking about it, and again, talking to different agencies about it. There are occasions where when one of these big emergencies on the roadway happen, an agency might even deploy a drone. Okay, I'm old-fashioned. I say drone, I will say UAV. We'll deploy a UAV over the area to see it. And it can be helpful to have the feed from that drone, from that UAV, come right into the administrative panel for the system. So we've successfully prototyped that, so we can now integrate UAV streams right into the panel, and it's on the map, so you can click it, you can see the video of it, and you can replay it if you need to and stuff like that. So that one's really cool. The second bullet in here of coming soon, which is coming really soon too, one of the questions we've been asked is, what happens if you have several thousand people in this trapped queue and they all start texting messages back to you? Okay, so for those of you who are participating today, I said, text back to me and I'll answer you. But what if everybody did that and you got like a boatload of them? And we've always said to people, well, you're just going to skim through and look for themes and stuff like this and then respond to everybody. But we decided what would be better is to put a little AI in there, a little artificial intelligence, and try to figure out using third-party like Google type, you know, cloud-based artificial intelligence, machine learning algorithms to see if we could get the intention of what somebody is texting back and then categorize those for you on the console screen so that I can see that I have maybe 200 people who are asking me about water. That's a really common one. Or I'm seeing that there's, 600 people who are inquiring about restrooms. So that, again, we've got our proof of concept done on that one. So we just have to figure out how to make it visually attractive in the system, and that will be coming in this year too. We were also asked about training, and we discussed all of our training needs. And one person in particular said that they would like to think about us to think about developing something maybe more robust in here. So we have come up with the idea of a training simulator so that we can have a situation and then we can simulate the responses from the people coming in and help the operator learn it through a preset simulation. So it's kind of cool. And the other one that we've been asked about, which I see pluses and minuses, but we're enabling it as well, is a photo and video uploads from participants if you want to turn that on or not as part of the system. So some exciting things that will be coming to the platform itself. So most of this stuff is available to people, automatically who already subscribe to it. And then that's it for, stuff that we're seeing in the very short-term future for that. So John, can you click to the next slide for me? And at this one, John in particular is in close touch with FEMA and the folks at iPause. And John, could you very quickly give us an update on iPause and COVID-19?
Sure. Yeah, I think we'd be remiss not to address the COVID-19 situation. So it was recently listening to a webinar by the FEMA team that runs the system, and some of the statistics that I put on the slide here is showing that there's been a lot of uses by a lot of different parts of the United States to announce things about COVID-19 and its impact on people in the area. Sometimes it's telling people to stay at home and things like that. But the part that I really wanted to highlight for this is that there are definitely traffic impacts and roadway impacts on some of these different things that are announced, like quarantines. So if you want to, it's a perfectly authorized use. If there's a certain highway where some towns have particularly strict quarantine regulations, if you get off at these next 6 exits, you're going to have to be quarantined for 2 weeks, otherwise keep driving through. Perfectly authorized use of something like a wireless emergency alert. Same thing for areas where you do have traffic impacts because you have a lot of people going to something like a testing center or picking up supplies, or my hope of all hopes is that there's great big lines because we're all waiting in line for vaccines in the near future. All those different things, as they're coordinated, are authorized uses of the wireless emergency alert system, and these kinds of things are being done in different parts of the country. So I just wanted to make sure that I talked about that really quickly. I'll turn it back to Mary. Mary, are you there?
Yes, I had to unmute myself, so sorry. Thanks, John. I just wanted to conclude in here that we see this tool as a way to be heard. And that's in 2 ways. One, for those people who are trapped in the emergency situation, it is a way for you as an agency to have your safety instructions, your what to do next, your way of communicating specific information to those people. You can be heard by those people. If as an agency you want to accept this as a 2-way and respond to people coming back in, you're letting the people in the emergency have the feeling that they are heard as well. So both the agency and the people in the queue are being heard. And that's a pretty powerful tool, and I think it provides a lot of comfort to people to know that the agency is aware that they are there and that they can make their voice known if they want. So thank you very much, and at this point, I think we'll go to questions, John, unless you have something else to say.
No, that sounds great.
Okay, great. Wonderful job. Thank you both so much. So a few questions have come in. First of all, from Scott Coward in Virginia, he asked if the states that are using the service are all currently doing 2-way communication.
I guess I'll take that one. The short answer is yes, for those states that have deployed so far. Georgia and Maryland have not done their full deployment, so I can't say. The plan is to do that, I believe, in all the states, but they have not released the final version yet.
And I'll just add on to that. I can just add on that I'm not sure that there's necessarily in the deployments, I don't know that people expect to be answered on every reply, but they know, but people do text back. Would you say that's correct, John?
Yeah, absolutely. And what we do is in the systems, we build in an auto reply to any text message that comes in, and it makes it seem like the line is not monitored. And hopefully those of you that have tested the system have seen that. But really on the back end, the DOT can determine if they want to respond or not to individual messages. Minimally, they have the ability to monitor it, though.
Very good, very good. And Matt Glasser from Georgia asked, could functionality be built into the system so that drivers traveling only in one direction would get the information?
That's a great question, Matt. And unfortunately, the answer is no, but I wish it were yes. When we're using that wireless emergency alerting system, one of the downsides to it is that we kind of lose control of the ability to make it as refined as we want. It winds up being up to the cell carriers to make that decision as to who hears the alert, being that they're in the polygon or not. And generally speaking, with a 1/10 of a mile radius on either side of it, that does wind up hitting both directions of traffic. So the answer is generally it will not be just one direction.
And I think he added a suggestion or an idea. He said, since the phones are being used to help bring in accuracy, could they look for 2 back-to-back pings? So maybe like, were you in the polygon now, or are you in the polygon 30 seconds later? Maybe that would help you target the stop direction.
And if we were using a mobile app, oh, sorry.
That's okay. Yeah, to John's point, if you're using a mobile app, yes. With this one, these are generally people who are stopped in traffic. So a sense of directionality is generally not obtainable. It would probably, you can do something with a mobile app as you're approaching something like a severe slowdown or approaching something. But the wireless emergency alerts from the federal government, it's literally broadcast, which means both directions. But it's a good idea, what you're saying with the 2 back-to-back pings, and that is how we do it in other applications. So good thinking. We're on the same page.
Great, and that's why we share in these environments. All right, one other question. Does HELP provide solutions to detour trapped traffic? And if not, who does?
It most certainly can be used to help detour trapped traffic if you like. So what would wind up happening is the DOT would send out an initial alert. It would hit everybody in that area, and then the contents of that message could change depending on who's going. So the initial alert would go to everybody, which is character limited and won't have a ton of information. It'll just have the very basics. But then if the person opts in, you could if it's a very short detour information, you could put in the emergency alert. But otherwise, the person could opt in, and then you could actually select everybody you wanted to and text them either a link to a page with detour information, or you could actually text them details of the detour directly. And the other cool part is, once somebody registers, they tell you what type of vehicle they are, so you could actually send different information to, say, commercial vehicles than you would to passenger vehicles, and different sets of buses as well. So you can actually divide, like if you had to, not direct big trucks over certain bridges or something like that, you can make sure you direct them a different way than you do cars.
Excellent, and that speaks a little bit to Mary Grace's comment. So while we go on to the next presentation, maybe you could just read over Mary Grace's comment, and if there's anything else you have to add to her, you could do that in the chat box. So with that, thank you so much, John and Mary. Always interesting and good stuff, and we appreciate that. But with that, we will move on to our next presentation, which is from Rick Schuman from INRIX and Gene Conti from Drivewyze, and they'll be talking about commercial vehicle safety alerts. So this feels a little bit like Old Home Week. I've known both of these guys for about 20 years, so this is kind of neat to see their faces right there on the screen. I wish we were all in the same room, but a little Old Home Week right here going on. So let me introduce them. Rick Schuman is INRIX's Vice President for Public Sector Americas. He's been with INRIX since 2006, and he was the first employee to focus on building public sector business. He's managed key projects for INRIX, including I-95 Vehicle Probe Project, and also the NPM-RDS, which is the Federal Highway's National Performance Management Research Data Set, which for those of you new to the industry or new to our coalition, that is the data set that we use for federal performance measures. So INRIX is now the vendor for that effort for Federal Highway. And also, he's been deeply involved in ITS and transportation operations for over 25 years. He was an original staff member at ITS America in the 90s, and he's currently based in Orlando, Florida. And his co-presenter is Gene Conti, who operates a management consultancy with his wife, whose practice focuses on business development and revenue growth for clients in transportation and telecommunications, as well as training and coaching leaders in those sectors. Gene has been the secretary at the North Carolina Department of Transportation. He has more than 2 decades of public service and private business management experience. He was a secretary at the Maryland Department of Labor Licensing and Regulation. He was an assistant secretary at USDOT and a vice president for PBS&J, which is now Atkins. And he shared something the other day that I thought was really interesting. Many of us remember the 511 coalition back in the early 2000s. And Gene shared that he remembers being on that original team that actually went to the FCC and petitioned so that we would have 511. So, Rick and Gene have been early leaders in our industry, and so thank you both for what you've done for our industry. Thank you for your roles in getting 511 off the ground. We wouldn't have Jim Hadden's presentation today if it wasn't for what you all did for our industry 20 years ago. So thank you from all of us. And with that, I will turn it over to Rick to get started.
Thanks, Kelly. Sound check, can you hear me?
Yep, you sound great.
Great. Okay. So I'll start. Gene will chime in here as we go through. It's as you'll see here, it's a partnership of the two firms, INRIX and Drivewyze. A couple of things as I get started. One, Mary Grace's question, I think we'll address as we go through too, this presentation. And as I was prepping for this, I tend to have a thing. Those of you that we see often, I'll tell you that there's something interesting. I'll use the word interesting. It's usually not good, but something interesting happening somewhere on roads in America right now, whether people know it or not. And there is, unfortunately for Matt Glasser and those in Georgia, there's something interesting happening right now that I think proves the point on kind of both the help use case and what we're going to talk about here. There was an incident, I-75 northbound, I guess nominally an hour north of Atlanta, that happened about 8:15, blocked the road. It looks like a lane's open based on what I'm seeing from our probe data. The queue is building. It's nearly 10 miles as we speak, and still growing, even though traffic is starting to move through the intersection. So rural area where there can be traffic and incidents, but you don't typically expect it to happen. There was a trapped queue, best I can tell. Vehicles have been trapped. We're trapped in there for up to a couple of hours so far. So depending on somebody's help rules, you may or may not have initiated a help alert. That's certainly possible. And then as I transition to this, as Kelly said, been doing this for a long time. When I started at ITS America, I was the young kid, and there were, we predated actually the internet, if you can believe that. We certainly predated smartphones, and as Kelly said, 511 was just a thought back when. But I've always been interested in the concept of business models in travel information. And some of you old-timers might remember that in the late 90s, pre-511, we actually did a Federal Highway and ITS America and all the members did a year-long effort on travel information business models because it's a complicated subject. Who has the information? It's a disparate set of agencies. Back then, it was predominantly looked at as agencies that had the information, and how would you distribute that to travelers of various types in various methods and so forth. And it's a very complicated soup. And so I've always been interested in travel information business models and those applications, and the world's only gotten, it generally improves, moves forward. We have, if you want information, you have a much better chance of finding it, but it still is a massive confusion. And as Kelly knows, getting what seemingly simple things like getting closed roads to display on all the various forms and uses that people have, whether it's government-sponsored information, sites or in-vehicle systems, mobile phones, it's complicated. So we've always been, in particular, thinking about, well, how do we get truck-specific information to truckers? Mary Grace's question here about rest areas in the chat box is a perfect illustration of that. There's a myriad of things and projects, and again, when I think about business models, it's one thing to do a project that you can prove a point. It's another thing for a scalable commercial system. And so I got personally interested in this as somebody both, as a professional in the community and somebody working at INRIX. When I saw last summer, as Gino described in more depth, Drivewyze went out with a release mentioning that they were doing safety notifications to trucks. And to me, I said, well, that's interesting. What does that mean? And Gino explained what those were, static-ish compared to what we're talking about here today. But it led to a dialogue between our firms and the marriage that we'll talk about here, where providing content, dynamic content, getting it into the workflow of truckers in a way to prevent incidents and improve overall safety of the network. We're calling it commercial vehicle safety alerts. It's a partnership of INRIX and Drivewyze. I think as professionals, we all know instinctively, we don't, trucks and cars tend not to mix well in let's say anything but free flow situations. The number of truck-related fatalities on the road network is increasing. even as overall fatality levels are holding steady. I guess that may make sense given just the overall increases in freight. And at the policy level, people understand that, right? We have state freight plans, we have state safety plans. They tend to overlap, but it's an area that is well understood as truck safety. I mean, after all, there is a Federal Motor Carrier Safety Administration, right? To speak to the concept of truck safety. So instinctively, we know this is an issue, but it's hard to kind of tease out exactly overall the extent of the issue and you know, what kinds of crashes, this and that. The data's sort of there, but it's hard to tease out. I'll commend, there's two efforts that are two studies in recent years that I'm aware of. If you're aware of others, please share. One was done by Purdue working with Indiana DOT, and they published a TRB paper about 4 years ago, where they actually had grad students go look at 3 years of crash data for every interstate crash that had a fatality, every interstate crash, period. There's something like 15,000 of them. And as you kind of look through this, you'll notice that the cascade of events of those, there were 230 fatal crashes over those 3 years across the interstate system in the state of Indiana. 30 of them were back of queue crashes. 26 of them were rear end. 25 of those involved trucks. 18 of those were in rural areas, and they were able to tease out, based on the data, that 13 of those 230 crashes were a truck hitting a queue in a rural area. Sorry, I don't have the fatality numbers there. I'm working with what's in the paper. So 13 crashes over a 3-year period where trucks hit queues. So another interesting point there, which dovetails well, and Ryan, I hope I'm not stealing thunder. I know you talked this afternoon. We've been collaborating with PennDOT on a number of things. I thought it was appropriate here, again, in this context. The Purdue study in Indiana had said that a queue was present when they're looking at secondary crashes. About 75% of the time, a queue was present 15 minutes or more. And a little over 40% of the time, a queue was present an hour or longer before there was a crash. In PennDOT, Ryan, I assume we'll go into much more detail about this, has taken a very statistics-oriented approach to looking at their network. They examine the intersection of several data sources, including crash data and our traffic flow data, to create a picture of conditions and then kind of track their action, develop actions, track improvements. Relevant to this piece here, related to commercial vehicle safety alerts, I want to underscore a couple of things. In the one component was a secondary crash study, and they've done this for a few years, but taking 2018 data, they identified over 1,200 secondary crashes on their core network. That's the network in blue on the map here. And so that's between 3 and 4 a day of secondary crashes. And again, consistently with the Indiana study, 82% of those crashes, secondary crashes, occurred more than 15 minutes after a crash, and nearly half of them occurred an hour or more after the initial crash. And you can also see from the graphic below, nearly half the time, too, the incident occurred more than 2 miles away or well upstream of the incident. So thinking about those things in those contexts, these things happen often. I'm tracking a live one now in North Georgia. And they say when we're tracking, you know, when we think about INRIX, we're the folks that provide traffic data. We have rich data, only improving in the almost 14 years I've been working at INRIX. And from that, well, pertinent to this application, we translate our data in this very granular speed data that many of you know and use, that we update every minute. We actually have some kind of event messages that we create from those various types. And germane to this application, we are focused on enabling and providing road closures, congestion events, so that's a queue, and actual dangerous slowdowns. That's a slowdown at the back of a queue, or in a case where there may not be a queue, a very small queue, where there is, maybe late at night a work zone or something that's causing people to slam on their brakes. Doesn't really create congestion, but creates a dangerous situation where there's a slowdown. Those are all types of messages that we're creating. We're creating in real time and updating every minute. We do that for the entire limited access road network across the U.S. And that is one key component to the fodder about what we're offering here with this service. So we provide what we think is unmatched data in the standpoint of not only do we have high quality data, leveraging all different kinds of sources, including the largest source of truck data in the U.S. That we've been utilizing for well over a decade. So we think we have, and we tailor that for certain uses and perfect tailor for this application. That's why we say unmatched data. And then I'll turn it over to Gene to talk about Drivewyze and the unmatched reach part of this equation.
Thanks, Rick, and thanks, Denise, for having us today. Thanks, Kelly, for that nice introduction. It's nice to be back together with this coalition. I did have a chance to chair the coalition back when I was secretary in North Carolina, and I always look forward to these meetings because there's a lot of great information shared. Also want to thank Jim and Mary and John for their great presentations. Really interesting stuff going on. So Drivewyze was started in 2012, 2013 as a bypass program. That program is quite mature now. We're in over 46 states and a couple of provinces in Canada. We have over 800 sites where we're providing bypasses to commercial vehicles all across the country. What we've done is to try to leverage that platform, which was built for the bypass program, to really start providing information to trucks on other issues that they may encounter. So we've worked with a number of fleets, J.B. Hunt in particular, on identifying high rollover areas, and we've worked with DOTs across the country to get that information. And then as trucks approach those areas, they get a message in cab, both audio and visual, that will tell them you're approaching a high rollover zone, slow down. And we've been able to analyze that data with the companies to see whether the drivers are paying attention or whether they're not ignoring those messages. And certainly the safety officers in those companies use that data to help educate the drivers to pay attention. We've expanded that to a number of different areas. In the COVID crisis, most recently, we expanded the notifications to include which rest areas may be open ahead. A number of states closed down their way stations and converted them into truck parking areas. We've been able to provide notifications about that to truckers. And let me be very clear about who gets the messages. These messages are provided to anyone that has the Drivewyze application on their vehicle. And we have over 2.5 million now. It's growing rapidly. 2.5 million trucks that carry our application. Now, very clear, not all of them are paying for the bypass program, but all of them are able to get these safety messages without paying additional fees. So we've been providing those to trucks, companies that want to opt in for these safety messages. They have the ability to get them wherever we have identified areas, working with the DOTs around the country, identified areas to be geofenced and to generate safety messages to those trucks. About 10% of those trucks are owner-operator trucks. The other 90% are the bigger commercial fleets.
And Gene, you guys started with a mobile app for bypass, right? And you still have the mobile app?
Yes, the mobile app is available if you're an owner-operator and you just want to put the app on your phone and not have to buy an ELD that's more expensive or whatever. You can download that app for free. So, and that's about 10% of that 2.5 million that are the owner-operators that maybe not using an ELD, but will use a free app on their phone or their tablet or whatever they're using in their vehicle. Again, we provide audio and visual alerts. Yes.
Yeah, and so as we kind of pivot to the service, just want to underscore what attracted us, other than know Gene and know the team well at Drivewyze, and we both share kind of partnership of innovation. As they were the first ones to use smartphones versus toll tags, like things for bypass. That we saw, again, with the interest in business models, they essentially are creating the network of truck telematics terminals, and so you do not have to go. You can go to their website and see all they're called ELD in the regulatory world now, electronic logging devices. But it's a device in these cabs that many truckers, particularly of the larger fleets, have embedded in their cabs that provide them information, share back and forth with their dispatch centers, and then also provide the logging operations for the federal requirements. In the old model, without something like this and the kernel of software that's included in those devices, to get this kind of reach, we'd have to do individual deals with each of these ELD providers. Basically, by partnering with Drivewyze, that gets done. And in fact, you saw the slide here with 2 million trucks. They announced the same week we announced this partnership last week, they announced they added another network ELD provider. And so as Gene mentioned, 2 million goes to 2.5 million. We think it's a virtuous cycle that will just continue to grow. And in short, how do you get to the most trucks possible? We think this is the pathway to do that. So the service we're launching is, we call it commercial vehicle safety alerts. It's the focus on the dynamic alerts, not static rollover locations, low bridges, those sorts of things. And it may be obvious now, but it's focused on trying to get safety messages into cabs in the direction they're traveling, when they're heading into trouble, or when an agency feels there's a message they need to know, truck specific. And so there's kind of two types of things that'll be part of this. One is the data that we provide on closure, slowdown, and queues. The agency, I think a key point here is an agency would license this service to say, I'm going to operate in my state. Truck safety is a priority for us. Then, as Gene points out, any vehicle on the Drivewyze network that operates in that state has the potential to get a message of either of these types, whether that's a closure, slowdown, or queue message. Agencies will define the thresholds by which they want those messages triggered, or agency-specific messages. Several states have, deal with in winter weather. You may have bans on trucks or bans on empty trucks. You can conceivably put messages, outside your state as somebody's approaching your state. Drivewyze will interpret that and share that with every truck heading that goes through, essentially hits a tripwire, virtual tripwire. They'll get that message. Again, based on these alerts, Drivewyze creates a geofence, very similar to what John and Mary talked about. But in this case, we can do in direction of travel. And then the alerts are shown. This is an image, screen capture image here on the heavy congestion sign is some sort of MUTCD-like messaging. We're working on that now. We look forward to working with kind of the early implementers, the states, to kind of guide those to create a message. As Gene mentioned, there'll also be audio messages. And again, anybody who's in the Drivewyze network, once they opt in, so that, if it's an opt-in type service, that some sort of message will be created. Says, do you want these messages? Folks say yes, and they will get these messages. So any state who licenses this would then, these 2.5 million vehicles, if they're operating in your state and on a road that's being monitored, when any event gets triggered, a message gets sent. All trucks in the network will get it if they go past that curve. And importantly, that we have, as many of you know, we have a longstanding contract with the coalition as part of the Vehicle Pro project. This is now an option as part of that. So if you're interested in that, reach out to Denise. We're happy to discuss more. So we have a couple of close-up slides that kind of focus, on what we think are the benefits of this. And Gene, I'll kind of turn it over to you for these.
Yeah, I think I'll not spend a lot of time on it, but we've found, working again with some of the bigger fleets, that when we've provided messages, we've seen reduced speed, reduced crashes, and we think this new service will lead to that same result. The other thing is that we'll be able to provide data to the states on whether and how it's working. We'll be able to provide that data to the trucking companies as well, so they can evaluate how their drivers are behaving in these kinds of situations. Very clear,
right,
that without an alert, when the truck approaches a backup or a queue, without the alert, it's a much more dangerous situation. We believe with a real-time alert, several miles out, that we'll see trucks slow down, and when trucks slow down, that generally slows down all the traffic around it, so it helps prevent accidents, whether trucks are involved or not.
Great. So that actually concludes our part of the presentation. I think we have a few more minutes for questions. Hope you can see the excitement. Hope it comes through in both our voices as longtime folks. It's kind of a marriage that we haven't been able to do before, and we're really excited about it.
Very good. Thank you so much.
There's a couple of questions here. Yeah.
Yeah, let me read those for you guys. The first question, it says, the typical database from INRIX, what is the % trucks versus passenger?
So it depends on the location and the time of day. We've actually amped up our, if anybody gets our alerts, you may have gotten several months ago, that we have massive data growth. We actually have about 10 times the data that we had a year ago. And so right now we're about 95% consumer and 5% fleets. But understand that's not because we lowered the fleets. We have significant fleet penetration in that. So, but that's, again, the idea there is that's the data incoming to us. We just have more and more data to allow us to ascertain conditions. But to disseminate the fleets is not our role, that's Drivewyze's role. So that's irrespective of the percentage of data we have.
All right, very good. Another question, did the PennDOT secondary crash study include crashes in the opposite direction from driver distraction or rubbernecking?
So I will let Ryan. Ryan has he has the floor next after the break. I will leave that to Ryan to address and answer. Ryan McNary of PennDOT.
Ryan, can you address that one?
Yep, I can do it now or later, but no, we did not. We looked at the same direction of travel. We have the ability to do that, though. We just never thought to look at the rubbernecking crashes that would be potentially secondary. So not yet.
Very good. All right. The next question says, the real question is, how can states kick this real-time information to the platforms which reach the most commercial truckers? 2 million trucks is a big reach. The largest commercial trucker smartphone apps reach about 1 million trucks. I'm having trouble with my little scroll bar here as well, including Trucker Path and Trucker Tools. I guess that was more of a comment than a question. So maybe you can write to that in,
Yeah,
you know.
that's exactly, I mean, it's exactly the point. I think we think that there is no other mechanism that gets, in one activity, gets the penetration rates like this. And again, I underscore the business model importance. So we don't want to get tripped up over the way station bypass part of this, but that's really the enabler that has led these ELD providers to put the Drivewyze software kernel in their devices. So they can offer to their fleets who want it, way station bypass services. So the benefit is, that all of Omnitrack's, all of Trimble's vehicles have this code kernel in it, even if only a percentage actually use it for way station bypass. So that's and from an INRIX perspective, we see that this is good and only getting better as far as the reach increasing.
Very good, very good. Well, there's a number of other questions in the chat box. I think someone brought up a really good point about, how do we decide, we as public sector folks, how do we decide where we put our energy in feeding this information to different companies and different APIs? And it's a great question, and I think, it would be a great topic for a future session, Denise and Joanna. I think that's a really good question. So I'll let you all kind of address that in the chat box, and Matt had a question too about does it only go to certain trucks. But with that, we want to respect our schedule for folks that might be calling in for certain sessions today. So with that, I am going to kick off our break. I want to thank you, Gene and Rick, for a wonderful presentation. Good stuff, interesting stuff, and I love that you're thinking about kind of the next generation. How do we keep moving this data out? We heard about 511, but what's really the next? I think it's cool that we call this emerging issues, because how do we get that even further? How do we get it to truckers and to others? So thank you for bringing that to us this morning. And with that, we'll kick off our break. There'll be a countdown timer on the screen. We're going to keep the phone and web line open, so you can just keep it up on your screen. And we ask that you will be back in, whoops, I didn't see what was on the top there. Did it say 11:20? Yep, be back at 11:20. So we'll talk to you then.
Kelly?
Thank you so much.
Kelly?
Yes.
Kelly, before
Yes.
folks go, one piece of information, because if they can't come back or whatever, the Q&A that's in the box, we will send that out to the speakers and ask them to actually answer those questions fully, and then that'll go out at the end with the presentations. Just an FYI to you.
Okay, very good. So with that, great.
Folks, it looks like we are at the 11:20 point. Are folks ready to come back on to the conference?
Yeah, Mary, I think that's good. Keep it moving.
All righty. Well, excuse me. Welcome back to part 2 of today's conference summit on emerging technologies for traveler information, focusing on the safety of all users. It's my pleasure to bring us back and take us past the noon hour and to our conclusion. There's still plenty of excellent content. And before I introduce our first speakers, I would just want to welcome the Tennessee and Alabama members to the coalition. This is really an excellent development, and I'm glad we can still call it the coalition. So with that, let me introduce our first speaker for this part 2, and that is Ryan McNary, Manager of Traffic Systems and Performance at Pennsylvania DOT, and his presentation is going to be on PennDOT's TSMO performance program. And for those who don't know TSMO, we say it all the time, but it's Transportation Systems Management and Operations, just to make sure everyone's on the same page. So let me tell you a little bit about Ryan. He oversees PennDOT's Advanced Traffic Management System, ATMS, Road Condition Reporting System, 511 PA, Genetec statewide video solution, and the Traffic Alerts dashboard, which handles crowdsourced incident data. Ryan also leads the TSMO performance management efforts, where they have successfully linked several PennDOT data sets with crowdsourced big data. In January 2020, the TSMO Performance Program released the first Pennsylvania-specific congestion pie chart. Ryan began work with PennDOT 13 years ago and has a bachelor's degree in geography and planning from Westchester University. Thanks for joining us today, and take it away, Ryan.
I appreciate that. How do I sound? Okay.
You sound great.
All right, good. So I was going to give a general overview, but our office is relatively new. So Traffic Systems and Performance has been around for roughly a year. We kind of shifted gears within TMC operations in general, TSMO, to move away from people management, TMC management, and separate the duties between the systems management and then the performance. We still work together. We're sister offices, but that thought process allows us to focus on our partners a lot more intricately, because I work a lot more with IT, database, the data providers, but then all that data that comes into our office is an opportunity to potentially advance operations and the cross-cutting avenues of what the data provides so far and what we've uncovering to planning and safety. So what I'm going to be going over today basically is a highlight of how we've integrated the data into our operations and how we are implementing new strategies to improve that. So for the sake of the conversation, brief overview of the Department of Transportation. We manage roughly 40,000 state-owned miles of roadway. We have approximately 25,000 bridges, a budget around $10 billion each year. But when we're overseeing this for operations, we have to keep in mind all modes. So we look at railroads, we look at our transit systems, all of our licensed drivers we're trying to keep in mind. But at the same time, our bicycles, our ports, Philadelphia was just recently upgraded to be able to accommodate the largest ships in the world. So we're going to be seeing a lot more trucks coming into Philadelphia and using our infrastructure down there. But we have approximately around 11,000, 12,000 employees. It fluctuates. But that gives you a brief overview of what the DOT is, since our audience right now is pretty vast. But for the sake of this presentation, all the data you're going to see and how it's been implemented, we did the analysis. Whoops. Someone maximize the chat. The analysis that we performed was on our core roadway network. So you heard Rick say earlier when he was going over the secondary crash study that the analysis was on that. So those are those blue routes. It originated from our 501 network where our IVR was, but then we've kind of taken that and replicated it towards performance. So it is it's a data set now that we can actually conflate and overlay to all the other sources that I'm going to cover. So Pennsylvania is approximately 46,000 square miles. We have 4 regional traffic management centers, 2 district traffic management centers, and a statewide traffic management centers that helps oversee our core roadway network and all of our arterials. But the areas that I'm going to be highlighting where we've integrated data the most, so we started with validating crowdsourced data for incident identification. So in Pennsylvania, we do not have computer-aided dispatch in our traffic management centers. So we wanted to offer a resource to our TMC operators that was going to be something to give them better situational awareness. I'll be going over that. I'm going to be talking about the Pennsylvania specific congestion pie chart, where we've kind of started to implement this already in our regional operations plans with our planning organizations. I'm going to be going over briefly some of the COVID-19 impact opportunities. So when there is a downturn in traffic, it gives us opportunities to work with the data to understand where we were limited before. So we've kind of linked that to some avenues where we're going to be adjusting things for road work and our policy around reporting road work. And then eventually, right now, this is something that we will have pilot studies going on this summer for queue protection and smart work zones. So you kind of saw what Rick talked about as far as queue protection. We will be implementing safety corridors, but then I'm going to have a new announcement today for the first time, something else that we're working on for traveler information when it comes to the queue protection. So getting into it, our TSMO performance program correlates approximately 34 terabytes of data. This was something that we started approximately 4 years ago. We didn't have a traffic systems and performance office. I was under TMC operations. I was the assistant manager of that. But I was always focused on we can use data to make this better. So the initiative came down from EDC4, and we needed to come up with an incident timeline. So at that time, I looked at all of our available data sets. So right now, for our TSMO performance program from the PennDOT side, we have our crash records, we have our incident management system, which is our road conditions reporting system. We have our RWIS stations. We have our maintenance database, so that tells us the PennDOT maintenance locations and any payroll, when they're out there, etc. But then most recently, we just tied in our traffic counter information and our weigh in motion information for trucks, and then our ATMS DMS message history. So all of that is then linked on the back end through Power BI to our crowdsource. So we have our speed data that speed and incident data that come from INRIX, and then we have our incidents that come from Waze. Now, I would be remiss if I would not kind of call out the team that helps me with this. We have an internal team of data scientists. I think it's ballooned now to approximately 5 or 6 that don't directly work for me, but it's a partnership with our IT from our OA level. That they like working with our data. But then I also have, staff within our office that very much understand data, and I have to thank them the most because I just have ideas, and we collectively come up with figuring out solutions, and it's a lot of trial and error. So validating crowdsourced data, part of that incident timeline EDC4 effort that we did for FHWA, we were able to pull this in, but what we found is that INRIX and Waze combined to detect around 86-87% of all reportable crashes on our core network. So in Pennsylvania, a reportable crash, an individual either needs to be transported from the scene in EMS, for example, if they're injured, or the car needs to be towed. So these are incidents that are definitely going to be causing a congestion event there. INRIX was picking these events up around 7 minutes, Waze around 9 minutes, and then our operators in our TMCs, our incident management system, was around 13 minutes. First to detect, not surprising, INRIX being in the world of speed data, we're able to detect the slowdowns around 50% of the time first, and then Waze was 27%, and then traditional around 24%. But this gave us an opportunity and an understanding that this data is powerful. We need to do this. An 87% look-in ratio is massive. So we devised a traffic alerts dashboard. So it's going to be getting a big revamp. But there's only one thing. I was going to go over this and walk you through it, but for the sake of time, I'm just going to give you some screenshots. It's a dashboard. It's like a news feed. So it comes in real time through those APIs from INRIX and Waze. They link together, so it wouldn't be duplicating traffic alerts. But then it also shows you real time on the Google Maps on the right-hand corner where you have your slowdowns, where you have your cameras, where you have your DMS boards relative to those slowdowns. But then also INRIX through their incident API and their congestion API, they give you head and tails of congestion. This is an opportunity that I saw that we could create a real-time incident timeline. So on the back end, right now, we are creating a real-time incident timeline that we can then go look back at. Or an operator can have open to understand, is that head of congestion or that tail of congestion growing or shrinking? Are the operational responses working? Are our people out there in the field doing or saying what they're telling us via phone? Because how many times in TMC operations do we know that that's not the case? So this actually was an incident we had last week up on I-80. It was closed for approximately, I want to say almost 8 hours. But it gave us around 40 different updates, if you can see in the top right-hand corner. So we can scroll from left to right to see all those historical heads and tails of congestion. And then it gives you all the various information that comes in through the INRIX API, Waze, and then what we were reporting via our incident management system. So that's one aspect that we've done to adjust operations and enhance operations for our TMCs. But one thing that was always missing, and something my boss has always wanted, Doug Tomlinson, is a congestion pie chart. He said, I want it. And I was like, okay, well, we'll try to figure it out. So finally, we came up and we had enough of those data sources that I went over that we're able to basically relate them all back to congestion events through the INRIX incident API. So on the left-hand side, you see here is the 2018 statewide congestion pie chart. So starting going clockwise, back to the question that I think it was Mary Lou asked, we are able to quantify rubbernecking right now for the congestion pie chart. We just haven't looked into the analysis for secondary crashes relative to rubbernecking. That is something, a great idea. I'm going to look at that. But we have 26% road work statewide, 21% was back to weather conditions. Recurring statewide is around 12%. Minor crashes. So this is something that was new that we brought into the congestion pie chart, where this has it's a crash reported by either INRIX or Waze, but it wasn't linked to a reportable crash, but it had a congestion event. Other incidents, disabled vehicles, etc., and then reportable crashes. So before we brought in crowdsourced data, we were around 20 to 25% unknowns. So that's something that was a kind of crux to this. So if you're ever looking to do this in the future, crowdsourced data is just something that's definitely going to benefit you here. But we needed a control. And when we looked at FHWA's efforts, we saw that they had a more urban congestion pie chart. So comparing our Philadelphia metro congestion pie chart, you see the differences there in the recurrent congestion. That's no surprise to a lot of you on the call right now that 28% of Philadelphia's congestion is recurring. It is very similar to what FHWA came up with through their case studies 15 years ago. So this is something was a first for us. And we've already started, like I said, to release this to our MPOs and RPOs to do better operations planning. Real high level, the one thing I kind of want to go over here is you can look at this a little further if you want, but it shows all the different ways we've linked the data. So the RCRS roadwork, maintenance database, any Waze roadwork. So we had to come up with a hierarchy. We put into play that if there is a crash, and it would be associated to a crash. If there's a crash and weather, we still had to call that a crash-related congestion. That is just a hierarchy we had to come up with. But on the back end, we still have the capability to understand weather-related crashes or rubbernecking-related crashes, etc. Rubbernecking, brief overview on that is we have an incident on one side of the roadway via the incident congestion API. On the opposite side, through all of our other data sources, we cannot associate any other incident, but we do have a slowdown above the historical norm. So then we would quantify that as a rubbernecking congestion. So I know I'm moving quickly, but I gotta get this in here. So the timeline of COVID. Now this gave us an opportunity. A lot of times when you have a downturn in traffic like we're all experiencing right now, this gave us an opportunity to kind of look into what of our TMC managers have always said is the way we handle roadwork identification to our TMCs is invasive to our TMC operations staff. So right now in PennDOT it's a phone call. There's nothing virtual, so there's around 400 to 500 phone calls that happen daily and approximately all around the same time. Now, we do have separate operations offices, but that's a lot of intrusion into their daily business and a lot of an intrusion that takes them away from traffic management or active traffic management. So what you're seeing in front of you right now is on March 16th in Pennsylvania, we had non-essential businesses closed. 23rd, non-life sustaining, and on April 1st, we saw the stay-at-home order. What this then gave us the capability to look at was how is that going to impact our truck volumes and our passenger volumes. So after we saw the first non-essential businesses close on the 16th, we saw all recurring congestion go away on our core roadway network. It was an approximately 10% drop in traffic volumes on our core roadway network at that time, but that shows us right there that capability to understand, okay, I mean, if we alleviated 10% of our traffic volume, we wouldn't have recurring congestion. And that was for everywhere in the state. We also saw incidents drop approximately 88%, reported through Waze. And on the 23rd, you do see a spike there because that actually was we had a weather we had snow. But what this gave us an opportunity to look at, and if you look further down the line here, is the construction resumes on May 1st. And back to what I was talking about, the intrusive aspect of the way we report is, now this is a intricate chart here. At 1, you'd be looking at a RCRS, our incident management system, to a Waze reported crash. Now, during this time frame, we averaged before the COVID responses having a 20% capture rate of RCRS to Waze reported crashes. Previously, what we've been able to quantify for that Waze crashes are correlated to approximately 86% of congestion events that last 30 minutes or more. So we need to get better from an operational perspective of understanding where these crashes are. So the best you would potentially be is a 1-to-1, but not, as we all know, not all Waze-related crashes are going to be accurate. So during this time frame, after the stay-at-home order, we went up to approximately 50% of all Waze-related crashes. But then after construction resumes, those phone calls that come back into our TMCs, we saw a drop back down to 24% on average for the month of May. So that actually showed us that what our TMC managers was accurate. So I'm in the process of designing a mobile roadwork app that individuals will be able to in-field on their iPads, activate, enter roadworks when they're on scene, when individuals are on scene. It will be open to external and internal partners, but it starts the cognitive transition towards lane reservation that we want to get to in Pennsylvania, where individuals would start to do an analysis and reserve lanes that a lot of your other states I know you're doing right now, but in Pennsylvania we do not have that. And kind of relates back to what I was saying before, be more proactive in our TMCs because we have more ITS devices that are coming. Signals is something that we really want to work towards in our urban areas. So Rick alluded to this pretty quickly, but I'm gonna go over the smart work zone side of this. Now this is built, and we are actually working on this implementation right now. We've designed the messaging that you see there. This was built to work on the I-76 corridor, which is our busiest road in Pennsylvania from Conshohocken to Center City, Philadelphia. I'm sorry, King of Prussia. It goes through Conshohocken. Maybe I just think of Conshohocken because that's where I always sit. But anyways, we were able to quantify that we had around 909 work zone congestion-related crashes in 2018, resulting in 3 fatalities. Now, that is a significant decrease to what we saw in 2017. We actually had 12 fatalities in work zone congestion-related crashes, resulting in around 702 injuries. 80% of those were rear-end crashes. That's a lot. So it's those dangerous crashes, dangerous slowdowns where individuals run in the back queue or running off the road to try to avoid. What was big to us and what we wanted to understand was how can we better give this information to the motorists as they're driving up. So these dynamic boards that you're seeing in front of you will update automatically based off INRIX or speed detector information where the cues are present. So XX miles ahead, be prepared to stop, or slow down ahead, etc. So with the information that we have in front of you, we are able to make a more intelligent way of our back-end deployment of this system. I appreciate Rick going over this. So this is something that we are going to be, the secondary crash study is something that we're going to be relating more towards how we can improve our traveler information. So Rick went over the fatalities and how we went and did this before. Most importantly, that I'd like to highlight again is the distance and the times where the queues were present. Back to the active management and how we handle our messaging and how they update dynamically. 48% of them happen over 2 miles back. We were able to understand through our analysis that 95% of our secondary crashes had DMS boards upstream within 5 miles. So we had the opportunity to alert motorists that there is an impending stop traffic ahead. But what's most important to this is it's apparently not enough. And then what we're working on is adjusting the way we want to relay future information to our motorists. So when thinking about this and thinking about the lifespan of our current highway advisory radios, it is a great aspect of ITS management, but its listen-in ratio is probably at its lifespan. So we most recently have worked with our internal team and Info Logistics to devise a scope and a plan to modernize highway advisory radios in Pennsylvania. So this is going to cross-cut various aspects of our current 501 deployment. So it would allow then an individual, an operator, to write a HAR message in their existing ATMS system to essentially prioritize the IVR, where that HAR message would go over top for the regional traffic report. It would then allow us to adjust the HAR sign beacons, where it would say, instead of tune to 15:30 a.m., call 511, and it would give them the traffic on demand report with a prioritized HAR message with the wigwags out there, etc. But this is kind of the interesting part that we thought through. We're looking into, and we're going to be designing geofenced push notifications with a read aloud option. So if anybody that has the app downloaded on their phone, they would have the ability, the operator could request a push notification for a major closure, for example, on one of our incidents. They then set a radius per business rules, and as they drive through that radius, a push notification will come in and say, major road closure ahead, be prepared to stop. It would also allow for a read aloud option. In drive mode, if they're using our 501 PA app, for drive mode, which can be overlaid into Waze and Google, it would read the HAR message to them. There will be a radius or a HAR beacon that will be on our website. You can click on and it'll read it to you. But then it's also going to link to 501 Connect. And for everyone else, that means help. So we want to link that because this is the first start to our operational response. So that's something that we want to at least move towards, starting the WIA, starting the iPause, because during our major closures, that is the natural progression of communicating to our motorists. And then finally, our regional traffic report, we're investigating whether we can have internet radio stations. And I think the next presentation you're going to hear from Kevin is really going to solidify this, because when we first thought up this idea, we didn't find anybody else that was doing this modernization of HARs. And it was great to hear the other day on the dry run from Kevin that Florida is considering this too. So I'm not going to take too much from the internet traffic radio stations there. But where we're heading next is we're working on an advanced weather analysis to automate protection messaging around snow squalls. It's been understood that snow squalls cause the biggest crashes. We're working on understanding alternative route, DMS message effectiveness, and then for our planners, we want to understand better where we can look at an operational deficient metric and understanding where we can implement better TSMO solutions to improve the safety of our roadways and then the operation of our roadways at the same time. So that is everything I wanted to cover, and I appreciate the opportunity to be here from the coalition, and I'll answer questions if there are any.
Thank you, Ryan. Right now we have one question in the chat box from Mike Pillsbury. Does roadwork include emergency repairs, or is that under other incidents? And that's with reference to your pie chart.
So roadwork would be anything reported to the DOT. Now, if it is Waze roadwork, I would imagine that is going to be an individual that just sees people out there. So right now, it's everything that we primarily use as roadwork is anything that's reported to the DOT. And from the PennDOT perspective, emergency roadwork or utility roadwork is something that isn't reported uniformly.
Okay. And then there's also a comment. You just have nightmares about the Conshohocken curve, maybe. And
it's true.
I don't know that needs a response, but I just wanted to point that out there. And I see that we're a little bit at we're just at 11:51. So maybe if anyone else has questions to put in the chat, we'll either get to it later today at the very end, or as we mentioned, there will be an opportunity for all the chat questions to be forwarded to all the speakers, and they'll have an opportunity to respond. So with that, Ryan, I want to thank you very much for your presentation, and I wish you all the best, and please keep us posted.
Thank you.
You're welcome. And our final formal presentation today is by Kevin Loftus, the Senior Vice President of Operations at iHeartMedia / Total Traffic and Weather. And his presentation has the intriguing title, New and Traditional Media in Traveler Information. Let me just tell you a little bit about Kevin. He's the Senior Vice President of Operations for Total Traffic and Weather Network, TTWN, which is a division of iHeartMedia. A native of Pennsylvania, he began his career in media and traveler information in 1989 with Shadow Traffic in Philadelphia. Since joining TTWN in 2003, Kevin has spearheaded the launch of the first nationwide broadcast traffic network for in-vehicle navigation, directed the integration of operations following the acquisition of Metro Networks, and led development of the T3 television platform featuring 3D rendering of interactive maps. In his current role, he manages TTWN operations nationwide with 26 regional hubs and nearly 750 personnel supporting the delivery of traffic information that reaches 98% of American commuters each month. Very impressive. And thanks for making the time to talk to us today. So, Kevin, it's all yours.
Mary, thank you very much. Very happy to be here, and thank you for the invitation. We see some old friends on the participant list and some old contacts from years past. A little bit about Total Traffic and Weather Network. As Mary mentioned in the bio, we are a division of iHeartMedia and iHeartRadio. Our specialty is reach. Our specialty is, we service over 2,600 media outlets across the country, so that's everything from television to radio from a broadcast perspective. Over 2,400 radio affiliates nationwide take our service. So that's your very traditional traffic reports as you have heard them growing up, and as you drive around, those traffic reports come out of our operation centers, which are still staffed, as mentioned, 26 operation centers across the country. In the last several years, we have greatly beefed up our television presence and what we and how we service our television clients with the addition of high definition graphics and also helicopters. Believe it or not, we still have 11 helicopters in the air around the country, and in 2011, we had merged with Metro Networks, which had bought Shadow Traffic from Westwood One back in the late 90s. So all of these things came together to what is today Total Traffic and Weather Network. Our current operations centers, and this is probably one of the things that gets lost quite a bit, is that we are still hyper-local. We've got 26 ops centers around the country where we are servicing our local media outlets. With the traffic reports that go on the air for radio, for TV, we're also servicing a number of auto OEMs with traffic information direct into the navigation systems. Our core customer is Toyota Lexus. We have a couple of other Tier 1 supplier relationships, but we're also a supplier of incident data to two other major Tier 1 suppliers to automotive, which puts our incident data into the dashboard of just about every navigation system out there that's getting its information via broadcast medium. In our major hubs, all of these, we're servicing all these markets, about 120 markets nationwide, but the hubs are largely our major 24/7 hubs are open. There's 17 of those. We've got another smaller regional hubs that operate during peak periods. So, for example, in pull one out here, Pittsburgh, we're operational in Pittsburgh largely during the day, so 5 a.m. in the morning to about 8 p.m. at night. Here's a look. We're the only ones that are still currently doing this. We're collecting information from old-fashioned scanners. We're talking to your TMCs. We are working with the agencies, as many agencies as we possibly can, because our job is reach. With reaching 98% of the people that are driving on a monthly basis, people are still listening to the radio, people are watching television, traffic reports are still out there. So we're the media arm. We're broadcasting, we're putting this message out to as many people as can possibly get it that are listening to our networks. So since 2020, since March, I think everyone on this call is certainly aware that we have experienced a significant downturn in what would have normally been considered a normal traffic pattern in any way, shape, or form. So we really had to kind of work hard with our affiliate partners on the media space, but also our content partners to try and change the messaging so that we were actually broadcasting traffic content, but it was also relevant to people in that world. So we really started looking hard at the COVID-19 testing sites, tracking where the testing sites were bubbling up and broadcasting those locations, and then focusing on congestion around the testing sites, but also food banks and anything else that was kind of outside the normal. So we really strived hard to put out a traffic broadcast that was very, very atypical to what you would a normal driver would expect to hear. So when we work with our management team, we work with our reporters, we really stress very hard that, you know, this was not an instance where a traffic report should hit the radio that says, you know, there's nothing going on today. We wanted to make sure that we were using the time that we had on the air to put out information that was relevant to drivers, because there was still trucking, there was still first responders, there were still people that worked in grocery stores and those kind of things listening to the radio as they're going to work. We want to make sure that we were getting information to them as much as it would be to the normal everyday commuter who was quarantined for the given time. We spent a lot of time in the last, I would say probably the last 6-8 weeks, really looking at the mobility trends and how the probe data suppliers that we work with and how the content comes into us, and looking at that really as when are things really starting to open up again, right? Looking at volume and how volume is changing during a normal rush hour, or what used to be a normal rush hour, and how that's impacting the way people are moving around. We have seen, I'm sure that it's been published out there by a number of other providers, but surface streets. We've seen a lot more congestion on surface streets. We've seen a lot more odd daytime travel. So less travel at 6 o'clock in the morning, 7 o'clock in the morning, as people are still working from home. They're commuting to the coffee pot in the kitchen as opposed to the coffee pot in the kitchen at work. So what we're seeing now is we're seeing midday. We're seeing a midday congestion that we hadn't normally ever seen before. There's more people out different times of the day, and it's a lot less predictable. And it also causes a lot more, I should say, a lot more severe incidents. We've seen a better than 12 to 15% spike in the severity of incidents that we report. And when we talk about that, what we talk about is, very severe incidents, multi-injury, multi-vehicle crashes that would block multiple lanes during a normal rush hour period. So between 6 a.m. and 9 a.m. in local time, we would consider that your normal rush hour. Rare that we would see overturned tractor trailers or severe incidents happening on major interstates in highly congested urban areas during those kinds of time frames. We're seeing that a lot more now, that there's less people out there, there's less congestion, people are driving a little bit more carelessly and driving faster, and we're seeing much more severe incident coverage. One of the things that is important to understand is how media changes. As we've talked about with Jim's approach to the 511 voice activation coming out of New Jersey with the Google and the Amazon Alexa stuff and everything that's happening, what Ryan's group is doing in Pennsylvania, people don't, I think, as new media approaches, and there is still very much a heavy reliance on traditional media to get this kind of information to travelers. In a study that was done last year by Jacobs Media, we're finding that radio traffic reports, 40% of people that get traffic information are still consuming it through traditional media. Radio and TV is still the number one driver and the number one area where people that are getting traffic information are still coming through traditional sources. So what we strive on doing is what's different about my commute. We call it exceptions-based reporting. People generally understand your main highways are congested, but we do the big things well. We go after the major incidents with multi-closures and multi-lanes and the things that people aren't expecting. And we've been pretty successful, I think, in getting those messages out through traditional means. So as this turns the corner, we get into where traditional media and new media is helping with agencies. It's taken a little while now. We've had a couple of setbacks, and certainly the COVID-19 stuff has had an impact on getting this to market. But one of the things, Florida Turnpike had reached out to us a little over a year ago with the idea that as they are looking to modernize their highway advisory radio programs, and how could they change things? How could they make it? How could they reach more people rather than just the beacons on the side of the road? Less people tuning into the low-power AM stations that they're passing. They came to us with the idea of, could we put an internet radio station up? Could we put a channel on iHeartRadio, on the iHeartRadio app, to talk about turnpike traffic? So as we started doing some research, there's a note in here from last year where VDOT was making some massive changes to their HAR systems. As we just heard, PennDOT's looking at it. What we're looking at with Florida is the opportunity to create essentially a dedicated channel on the iHeartRadio app called Florida Turnpike Traffic. The pilot project was essentially is going to look at the south and east regions of the turnpike. So we will go from Miami north up to about Fort Pierce, where we're going to be looking at about 235 miles of turnpike highway, where we will accept messages from the Florida Turnpike. So the Turnpike is actually providing us with the audio files. So they're giving us audio files. We're taking those. We're hosting them on this new iHeartRadio channel. We have intermixed those Turnpike messages into a content wheel that would also include our recorded traffic voices from currently from West Palm Beach and from our Miami operations, so that there's consistent content on the channel all the time. The channel is designed to be up 24/7. It's running. We're working with the Turnpike where they are essentially giving us an API key where we can take their audio messages and then just dump them onto the channel, and they sit there and they will run over and over and over again. So this is also an example of one of the beacon signs and what the mock-up would look like should this get going. We would also be looking at to make sure that we can promote the channel so that the people that are iHeartRadio users or are interested in getting onto the iHeartRadio platform, there will be some signage in the service plazas and also some PSAs that run at the video signs at the gas pumps and the service plazas. So phased approach initially came at this from a let's start initially with just hosting the audio files. Let's do this over a few months, see what kind of momentum we can generate, what kind of listenership we can generate on the channel, and then start evaluating. Should this become something that we find that we are reaching people and people are tuning in and it's having the desired effect, the idea then would to look at a phase 2 approach where we would start to add additional segments of the Turnpike system into the channel. And then hopefully after about 9 months to a year, if the program continues to expand and the reach continues to grow, we would look to start enhancing services for it to include, potentially location-based advertising and location-based alerting. So we would actually use one of the engines that we use for location-based advertising. We would use that same platform to push alerts to people listening to the channel, so that we could make sure that we are, pushing people that maybe they're not near a beacon, but there's something coming up that they can get access to the audio content. Future opportunities and other things that we're looking at is, again, this would be a channel that's going to be dedicated to the Turnpike's use. So the idea would be that the audio files that are currently generated out of their HARS system, if they were going to host severe weather updates, evacuation support, floodgate messages, all of these things are content elements that can absolutely be added to the system over time. So that's actually the last slide I have. I've kind of run through this pretty quickly, but I did want to play. I'm going to see if I can make this work here.
Trail at Belvedere Road. We have some new construction popping up in North Palm Beach along North Lake Boulevard westbound at US 1. That's blocking a right lane. Fallen power cables now all cleaned up on Dixie Highway just north of Yamato. That's traffic. I'm Chris Ball.
Disabled vehicle in Miami-Dade County on Florida's Turnpike southbound at exit 34, northwest 106th Street. Right lane of 3 lanes blocked. This event was detected on June 17, 2011, 54 a.m.
Taking a look into Miami-Dade police activity still has to shut down on Northwest 199th Street between.
So that's a little sample. I hope that came through, but that's a little sample of what the channel sounds like with the automated messages coming in from the Turnpike, but also with the enhanced voice coming in from our operation centers. And one of the things that we have been in discussion with the Turnpike about to make the channel a little bit more user-friendly is eventually incorporating, potentially our voices coming out of our ops centers to read the Turnpike messages as opposed to the machine voice. So with that, kind of rushed through it a little bit, but I realize everyone's got to be getting tired, and we're coming up on the end of things here and certainly for lunchtime. So with that, Mary, looking for questions or comments.
Okay, well, thank you so much, Kevin. That was really informative, as were all the other presentations. I'm looking in the chat box now, and I'm someone's typing, but I haven't actually seen the question come in yet. So, here it is. Chester Osborne is saying, what is the SAT downlink footprint, and are there any geo area restrictions from the FCC? And could this be used in a small state? So this is a two-part question. Could this be used in a small state such as a Massachusetts, Connecticut, Rhode Island, New Hampshire, would be in the footprint of broadcast as well?
I'm not necessarily sure I understand the question with regard to satellite downlink footprint. So the iHeartRadio app is an app that you can download from the App Store or Google Play. It's available on any of the device stores itself. What we are talking about doing is adding a channel. So in the midst of the iHeartRadio app, where you might have local radio stations or content, it's streaming media, streaming audio. So we are going to create a dedicated channel designed for the Florida Turnpike information for listeners.
And my mistake, that wasn't a second question. I just misread it. It was basically the footprint, and then could then be used in a small state, which would be within the footprint of the broadcast as well. And he says,
sure.
And then Chester asked, oh, go ahead.
Oh, sorry, Mary. Yes, we can absolutely, because we own the app, it's bandwidth, so we could create a channel for any state really, and the hope is that the Florida Turnpike channel expands potentially to look at a wider, wider state of Florida content and information. So the goal really of the pilot project is to really generate interest and see how things take off. But this is an opportunity for us to potentially take the same technology and add channels for other states should it become an opportunity.
Great, and thank you. And Chester adds, got it. I see how it differs from HAR broadcast. Thank you. So basically, this is my own question, Kevin. So just any state could download the app and try to work with you to incorporate this type of service that you're providing on a basis, on a sort of pilot basis with Florida Turnpike.
Sure. We are, I kind of skipped over it a little bit in the beginning, but, TTWN we used to play a lot in the public sector or in the public sector, public agency space. Right about the time in 2011 when we made the acquisition of Metro Networks, we had refocused our energies into combining the operations of the companies and really heavily focusing on broadcast. And shoring up that business. So, we are pushing hard to try and, bring these kinds of elements into the public agency arena and start working more with government agencies, recognizing that we're partners in terms of data collection and data dissemination. So that's really our goal. So Florida is the first. We hope there's more, and we'll go from there.
Great, thank you. Let's see. I don't see anything else in the chat box right now, but I think people are typing. So we do have a few minutes. I'd like to just give a little bit of time to see if anybody has any other questions. And I know you had mentioned about reach, and that's part of your business model is trying to get reach. Can you also address whether there are any aspects? I know we talked a little bit about geofencing, but artificial intelligence, some of the technology behind the media. Is there anything that you've either learned or have been enabled to do because of these advances in technology that maybe you'd like to share with the group?
Well, I think that we can we can tell you that in Florida alone, so from a geofencing standpoint, we have, prior to the March shutdowns and things, we were able to determine that we had about 2.5 million listeners, I would say unique active listeners in the state of Florida alone. So that was one of the metrics that we were looking at in terms of, just how, the iHeartRadio platform has millions and millions of listeners on it from all over the country. So the idea was to try and narrow the scope to determine just how much of the user base and the audience on the iHeartRadio app was centralized in Florida, and that was meaningful to the agency. So, we've got a significant audience already listening in the region, so we're hoping that brings it out.
Okay. Well, Ray, thank you for that. And Ray Halavant says, speaking of reach, the 98% you mentioned is nationwide via celestial radio. What do you see as your reach on the Florida Turnpike, or I guess potential?
So, yeah, I can get those numbers and provide those back to you. So the 98% reach, as you mentioned, is nationwide. That is the reach that combines the television audience with the television folks that we're reaching, and also the radio stations that are part of our affiliate network in the market. But I can certainly get for you for the southern and eastern segments of the Turnpike, where we're looking at for the pilot project from a radio reach and a broad media reach. I can certainly provide those.
That would be great. Thank you. Any other questions coming in on the chat? I don't see any. And we're at the, I guess we're at the 12. Oh, did someone want to speak up? I just heard someone. No, maybe not.
Mary, this is Denise.
Okay, Denise.
I think just in your wrap-up, I think before you wrap up, I want to say, I think I need to say thank you to both you and to Kelly for doing an absolutely fantastic job in managing and facilitating, the presentations today. It was really, really well done. And we really appreciate the work that you two do on behalf of the Travel Information Group. The other piece of information I think that we also need to do a shout out is to KMJ Consulting, because they are the folks that you all work with and really manage this whole web thing pretty well. Given our COVID situation, we'd love to be in person, but I just want to make sure that I get a thank you to both you and Kelly and to KMJ before you continue. Coalition is very, very happy.
Well, thank you very much. And since we're thanking people, I want to thank you and the ever expanding coalition. Talk about reach. I want to thank you and staff for putting this together. And I would definitely be remiss if I didn't thank our participants. I mean, as well as our presenters, because you need a good audience, which we have, and you need high quality presentations, which we really had, and I think those are also important ingredients for a good event like this. And I think that, not that there's a silver lining in a pandemic, please, but I think that one of the things that working remotely has enabled us to do is really increase the participation numbers. We've got a lot of people on this call, on this meeting. Many people have stayed through the whole event. We got a lot of good visuals. We got a lot of good feedback, and it's saved people impacts on the air quality and the environment and everything else, because no one had to go anywhere. I think we're all safer in our homes or wherever we're at than had we gotten into some kind of public transportation or personal transportation and run the risk of becoming a statistic. So there is an upside to this, and I think it's topical because we are talking about safety, and we are talking about travelers and helpful and enabling information. So good job all around. My last job, I think, is to wrap up. The chat box is still open. If anybody has any further questions or comments in the remaining 10 or 11 minutes. But I did want to say a few things about next steps and what's going to happen. The meeting information and all the presentations will be posted on the Corridor Coalition website. Give us a little time to pull all that together. But everything that you saw here today will be available. It is going to be, it has been recorded, and so that recording will also be made available. Anybody who signed up is going to get a link to all the presentations once they are posted. And there will, I can just tell there's going to be an awful lot of follow-up not just from the coalition as an entity, but also amongst the attendees and amongst the participants, because I think we've all gotten some really excellent ideas, and our imaginations have been sparked to think about what we can do and base what we do on ideas that we shamelessly steal from our fellow coalition members. So with that, I think I've covered all the wrap-up topics. I mentioned that we are some key takeaways that I've heard are the use of AI, geocoding. There's so much more information streaming from multiple sources, and the ability to take that information timely and turn it into understandable, informative graphics and pie charts is just that's not artificial intelligence. That's human intelligence taking all this information and presenting it in ways that are really very understandable and offer a lot of insights. So this is a great place to be right now. We are as a coalition and particularly this program track. You can see there's a history of not just helping the public, but also helping each other. Right? I lost count of the times when presenters today made references to other presenters today and topics that they're working on or other projects that they've collaborated on. And I think with that kind of community of practice, this is the sky's the limit in terms of where we can go with some of these innovations. So at that point, I want to again thank each and every one of the presenters and each and every one of the attendees, and I'm done talking. We've got a few minutes left over, so if anyone from the coalition, anybody that's got their speaker enabled, please feel free to chime in with any final words. But thank you, and stay safe.
Mary, what we will do is we will keep the chat box. We'll keep the chat box open for about 10 more minutes in case there are any questions that people do want to put in the chat box that we can send to the presenters. We've been doing that lately, and sometimes somebody will think of something, so we will keep this chat box open for another 10 more minutes. Okay? Great.